Okay, I'm with Dave Markham here on Arban Drive, and I'm here to talk to Dave about his grinder pump failure. Now, his grinder pump failed. It was over 4 years ago, so it's a long time, but it's a case that I wanted to bring to the attention of the grinder pump owners, especially those who may have generators, but also this will apply even to those that don't have generators. And the reason why there's such a delay in this video is because of the fact that the town had contested the details on this case, so I didn't want to really discuss this in public until after that had been resolved, and that has been resolved now. So now it's appropriate to talk about this, and this will all be reviewed by our counsel anyway before this gets released to the public. Okay, so now, the actual details of what happened in the Markham case are on the SFA website in great detail. Anybody who is interested in that, I encourage you to go to the Sewer Fairness Alliance website in Chelmsford, and you'll find a very detailed explanation of everything that happened on that day. We're not going to go over that here. Okay, we're just going to go over the type of failure that happened because it might apply to other people. Okay, and so I'm going to go over this, Dave, and I want you can just ask questions, or you can play a little bit of role of audience here because this will all sound very familiar to you. So what happened on that day that there was a power outage, and right now what I'm showing is a shot of the grinder pump. Okay, and when the power goes out, the water level in the grinder pump cavity will begin rising, and that's because the pump's not operating. It requires electricity. The pump normally operates between 24 and 32 gallon level in the tank. That's only an 8-gallon swing. It'll turn on as soon as it gets up to 32 gallons, and then it starts pumping, and when it gets down to 24 gallons, it turns off. Now, when the power is off, the water will start rising. When it gets to 47-gallon level, that's 15 gallons over the high level, that's when an alarm will go off. Now, that's 15 gallons. That's not actually that much. So an average shower is 8 minutes, and the average consumption of water in a shower is 16 gallons. So, for example, if you were in your shower or were about to take a shower and the power went out, that alone would be enough to put this into the alarm level. Now, many people don't have a remote sentry, which is a battery-powered alarm. Dave has one, so in his case, that alarm went off. But in other cases, no alarm will go off. Now, right above the alarm level in this picture is where the electronics in this grinder pump are. That's the on-off switch, basically. Okay? And when the water rises above the alarm level, that electronic cavity essentially is submerged, and moisture can get into it. Now, it's supposed to resist any moisture because it has rubber gaskets, but those rubber gaskets will age, and as a unit gets older, it'll be more likely to have moisture get into it. Also, the number of times that a unit is submerged, and it will get submerged in a power outage, whether you have a generator or not, because in this case, for example, Dave had a generator, but he turned it on after the remote sentry alarm level was on. So that means it had been submerged. Okay, that means there's an opportunity for water to get in there. Now, in this type of an appliance, the number one source of failure, even under normal operating conditions, is moisture in the electronics. That causes the electronics to fail. And that just happens even under normal operation after many years. That might be a failure. But it also can happen if there was a failure in the water tightness. Then it would fail earlier than that. That would be like defective units would fail within the first couple years because there was water intrusion in there. Okay. Now, Dave's unit was a rebuilt unit, but the gasket, for example, is not part of the rebuild procedure, so we don't know how old that unit actually was, and there could easily have been water intruding in there. And on the report from the technician, the number one listed cause of failure was the power outage itself. And this could easily have been what he's referring to. The power outage itself means generally that the pump will be submerged. Okay? How's that sound?
Perfect so far.
Make any sense?
Yeah,
okay.
Makes sense.
Okay. Now, when a grinder pump fails, the motor cannot turn, and when the motor does not turn, the motor draws a lot of current. So this grinder pump draws 20 amps of starting current, and when the rotor is not turning, it'll draw 20 amps. And in this case, when there's a short in the electronics, the motor will draw high current, and 20 amps is basically the number. Now, 20 amps is enough, would be enough to trigger circuit breaker. So this is the front panel on Dave's generator. Now, the 240 volt output is right here. Okay, that's providing the, in this case, all of the energy for the grinder pump, but also for the electrical panel in Dave's house. This is an 8,000 watt generator. Now, E1 recommends 6,000 starting watts in order to start the grinder pump. And the basic idea there is it needs 20 amps. Now, this actually can provide 30 amps, and that's because it's 8,000 watts rather than 6,000 watts. But the thing about this is, this 30 amps is also, aside from operating the grinder pump, is also operating other units in the house. So a grinder pump, when it's operating in the normal, non-failed, is only drawing 5 amps. But when it goes into a failure mode and starts drawing 20 amps, that's 15 additional amps that it's not supposed to be drawing. And that additional 15 amps is enough to trip off a breaker. Now, on this unit, there are two 30 amp circuit breakers on the 240 volt circuit, and that's because in a split phase power system, 240 volts is actually composed of two legs. Each of them is at 120 volts, but they are opposite in polarity, and that produces 240 volts. What happened in Dave's case was that one of these circuit breakers tripped. Okay, that gave the appearance on this meter that the voltage was 120 volts, but this meter is after the circuit breakers, so this is not actually the voltage of what's coming out of the generator. It's only the voltage of what's after the circuit breaker. When one of the breakers has popped, this is reading 120 volts. Now, the failed grinder pump caused the circuit breaker to pop because the current went too high. Okay, now this could happen to anybody who has a generator that has these independent circuit breakers. There's nothing wrong with these. These are allowed by code. Some units will have a circuit breaker that they're ganged together, so then one of them pops, they both go off, okay? But this is something to be aware of. Now, I said earlier that even if your grinder pump, you don't have a generator during a power outage, when you go to turn the power back on again, the grinder pump will have been submerged quite likely, and therefore within the next couple of days after that, or even quite a long time after that, that moisture which was present there can be responsible for a failure. And it really doesn't have anything to do with anything that you did. It's just that the water level was able to get too high while the power was off, okay? So that's basically everything, all that I wanted to point out here. Dave, did you have any questions on that now?
No, I think everything sounds right on.
Okay, great.
Just
Look,
the way
I
things happened.
wanted to thank you for your work in this case to allow the Sewer Fairness Alliance to investigate this, because this is a case that can be important for everybody. We have power outage season coming up now in the fall. And once again, I just wanted to point everybody to the Sewer Fairness Alliance website if you had any questions regarding this. Thanks.